Hello people, good night. In here I will present to you about my research, and my research is about synthesis of modified graphite with high crystalline sodium lithium titanate oxide by simple doping methodology. So for the introduction, lithium-ion batteries are energy storage that has high specific energy density. Because of these properties, lithium-ion batteries were used for electric vehicle applications. Lithium-ion batteries have three main components: anode, cathode, and electrolyte. And these three things will affect the electrochemical performance of the battery. There are two types of anode materials. They were graphite and lithium titanate oxide, or we can say LTO, which both have their respective application. Graphite is commonly used in lithium-ion battery compounds, in notebook, hybrid electric vehicle, and some electronic that did not require high electric currents. But LTO was a material that was often used for electronic that requires high electric currents. Otherwise, the high energy density and low-cost material made graphite as a material that was frequently used for lithium-ion battery applications. However, there are several problems as an anode material in lithium-ion battery, specifically for graphite. Graphite had a disadvantage when it was used at a slightly high current. Dendrite formation could occur, which was cause a problem with a battery performance. The most dangerous problem with dendrite formation is increasing the temperature operation. Several research developments related to graphite have been carried out to find solutions to the problem of dendrite formation, including surface modification, that is, modifying the surface of graphite by coating with other materials, and make a graphite with mesophorous structure, and adding some carbon nanotube. In this study, we developed a new method to solve the problem of dendrite formation by adding lithium titanate material using a simple doping methodology to minimize the cost of production, specifically to improve the electrochemical performance. Because LTO has a high operating voltage, 1.5 voltage in half cell, it means LTO can prevent the formation of dendrite even in high current condition. But the graphite, because the graphite has low operating voltage and the voltage is 0 volt in half cell, make graphite have a problem dendritic formation. So in here, we want to adding LTO in the graphite to prevent the dendrite formation because LTO have a characteristic to prevent the dendritic formation. So for the experimental, the first is the synthesis of sodium lithium titanate oxide by solid-state method. The material that we use is lithium hydroxide monohydrate, titanium dioxide, sodium chloride, and ethanol. This material to make sodium lithium titanate oxide. After the synthesis process is complete, sodium lithium titanate oxide is sintered at temperature 800 degrees Celsius for 12 hours to produce sodium lithium titanate oxide powder. The sodium lithium titanate oxide powder was mixed with graphite through a grinding process for 1 hour. The samples were varied by adding sodium lithium titanate oxide to graphite, namely by G-NaLTO1 is a sample for graphite with 1% adding sodium lithium titanate oxide, and G-NaLTO3 for the sample adding 3% sodium lithium titanate oxide to graphite. The material mixture is then sintered for 1 hour at a temperature of 600 degrees Celsius under nitrogen conditions. And the configuration of the analysis for XRD and electrochemical test. The XRD configuration was at frequency 10 degree to 80 degree. And the electrochemical test configuration is we use full cell and LiFePO as a cathode, and the composition that we use is 80% for active material, 10% for conductive material, 2% and 8% for binder, and its weight ratio. And for the analysis, the XRD analysis result showed that the pure graphite G-NaLTO1 and G-NaLTO3 samples did not show any significant change at the G-NaLTO peaks because the amount of sodium lithium titanate oxide that we add was so small. For battery performance analysis, the G-NaLTO1 sample has a highest specific charging capacity, and it was 356.69 at rate 0.1 C. To determine the effect of the addition of sodium lithium titanate oxide to prevent the dendritic formation, we charge and discharge again at rate 1 C, which indicate that the initial specific G-NaLTO1 was still at 220.65 mAh per gram. And this data indicate that the addition of sodium lithium titanate oxide has the potential to improve the performance of the graphite material. And to make a comprehensive study, we compare our result with another study. The simple doping methodology that our research produced a material with a performance that was not much different from the result of other studies. As we can see, in this work, we have the result 220 at rate 1C. And if we compare to another result, our result is much higher than the other. For the reference 11, 324 at rate 0.2 C, the rate is so small. So because the rate is so small, the initial charge capacity will be higher. So this shows that the methodology of adding sodium lithium titanate oxide has the potential to be used in improving the performance of graphite materials. So this is our references for our research, and my name is Muhammad Iqbal Putra. Thank you very much.